Hello everyone. In this lecture, we will see how you can find the maximum likelihood estimator of the Poisson distribution. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute. So what is that? You have to find the maximum likelihood estimate for the parameter this lambda of the Poisson distribution. Why? And also you have to find its variance p. So all of you know that for the Poisson distribution, there is only one parameter called as the lambda, which is nothing but the mean as well as the variance. And this is the PMF of this Poisson distribution. And our target is to find the maximum likelihood estimator for this parameter lambda. So as we discussed in our last video related to the MLE, maximum likelihood estimator, we can define this likelihood function L with the help of here. We can substitute the value of this PMF or called as the PDF or PMF. In here we will get this expression. Now since this is the product of them, now your target is to maximize them. How you can take them? You have to take the derivative with respect to lambda. Since it is a product form, it's quite lengthy, so we have to take this as a logarithm. So what is that? Product of is converted into the summation parts. Now you can apply this log of a upon b, which can be written like of this here. Now this is the exponential power are there, so minus of lambda can be taken as outside, log of e as a 1. Since this is the summation which is over the I, and since this is the parameter which is independent of I, so I can written as of n lambda. Now here we can now our target is to maximize this parameter as lambda. We can rule is we have to find the derivative. We have to check the second derivative and we have to prove that whether it's less than or not. So what will happen if you take as a first derivative with respect to parameter lambda? It will be my minus of n plus, because this is the independent of lambda, so it will be the 0, and here is 1 by here. So can you find the value of lambda from here? You can easily find the value of the lambda, which is nothing but here, or you can simplify that this is nothing but my sample mean. So once you will get the value of the here, that is a value of lambda, now you can find the second derivative. What is the second derivative of this? First derivative is my this. Now you can find the second derivative, which is nothing but here. This value is the positive quantity, so it will always be a less than 0. So what is the meaning of that? This, that is lambda, is nothing but my x bar, that's a sample mean, is maximizing this parameter. Hence the maximum likelihood estimator of this parameter is the sample mean. However, how you can find the variance of the estimator? So once you will prove that, once you will find the MLE of the parameter this, then the variance is used by this formula. This is the expected value of this here. Now what is that? Since in this case there is only one parameter associated with them, so you can write this either as a partial derivative of here, or you can use them as of here. Now what is the value of this part? So since we already computed by here, it is a minus of 1 by lambda square, so we can substitute the value here, which will get this one. How you can find this summation of the xi's? It can be taken from here. What is that? This is nothing but my nx bar. So once you will substitute the value here, this is the expected value of this into nx bar. Now n upon lambda square is the constant value, so it can be taken as the outside, so this can be written as of here. Now what is the value of the ex bar? So since we computed as ex bar is nothing but the lambda, so we can substitute the value also as of here. So since lambda is a constant value, so what is the expected value of the constant? This is nothing but here. So 1 lambda will be cancelled out. So what is that? This 1 will be cancelled out. So the right answer is my n by lambda. So therefore you can find the variance is nothing but my lambda upon n. So this is the variance of this maximum likelihood estimate of the Poisson distribution, and this maximum likelihood estimate is my sample mean. So this is the way you can find this MLE. In our next class, we will see how you can find the MLE for the geometric distribution. Till then, you can simply follow this link for finding the various video. Best of luck, students. Thank you.